Hello, everybody, and welcome to the Wednesday night show with Chris of MRL Trains for the Arduino workshop. I want to say go to YouTube Mall Builders. There you can check schedules for the Wednesday and Thursday shows. Those the Tuesday and Wednesday shows air at 8 o'clock Central, 9 o'clock Eastern Time. Thursday shows at 9 o'clock Central, 10 o'clock Eastern Time. And we're starting out the month of May now, so hopefully we got everybody on schedule. Don't have to reschedule or cancel any shows this month, but we shall see. So let's get over here and see who all's around. All right, we got everything going there. All right. And I'm going to turn it over to Chris. So this is all yours, Chris.
Okay, well, welcome back, everybody. Another Arduino workshop tonight. And speaking of cancellations, I hate to be the bearer of bad news, but I won't be available next month. So unless somebody wants to jump in and substitute, it'll be July before I see you again. But here it is, May already. It's hard to believe. And summer's coming quick, and I know everybody's going to be busy, so hopefully it won't be missed too bad. But tonight we're going to do something I talked about last month. Kind of for me, it was the holy grail of Arduino, which was to get connected to JMRI using the CMRI interface that's built into JMRI. When I first got into the Arduinos, my whole goal was to be able to do my own electronics, you know, with a lot of little projects we've been doing, but get it connected to JMRI and be able to run everything from the computer. All the projects we've done so far have been standalone projects, if you will. You know, you go mount them out somewhere on the layout and it'll do its thing, but you really couldn't control it from, let's say, a dispatcher's panel or have it interface with anything in JMRI or anywhere else on your layout. So to me, that was my ultimate goal, because I always knew I would be using JMRI for dispatching, and I finally got around, now that we've done enough projects, to figuring out how to do it. And there are other ways you can connect, like Greg has been working on a LocoNet shield. I mean, if you're running LocoNet or on your layout, if you have Digitrax and you're running a Digitrax system, you have a LocoNet. I know a lot of other guys with other systems will run a LocoNet, but I wasn't planning on doing that, so I had to find a different way to be able to interface with the computer, and it turned out that CMRI, which is just about the same as JMRI, only it's a C instead of a J, but that actually is Bruce Chubb's old computer model railroad interface that existed before JMRI or a lot of the computer and electronics that we have nowadays. But fortunately, JMRI has that built right into it. You know, just like you have an NCE connection for JMRI or a Digitrax connection, there's also a CMRI connection. So if you had an old CMRI system set up, you know, for signaling and turnouts, all the other inputs and outputs you use on the layout, that's already built in. So once I found out that there was a library out there that lets your Arduino pretend it's a CMRI piece of hardware, well, then we're golden. So took me a little goofing around to figure it out, and I know there's other guys out there that were playing around with it too with limited success. But I finally cracked, there's one or two little gotchas that if you don't get it figured out right, kind of keep you from being able to use it. So that's one of the reasons I want to do this tonight. So now we can literally start to throw turnouts with your computer rather than having to go over and push a button. You know, a lot of the projects we did push a button to throw a servo or to turn on a light or whatever. Now you can do it with JMRI, and it's quite simple. Even if you don't know JMRI inside and out, or you're not a JMRI expert, I know a lot of guys are using it anyways because they're using, if nothing else, they're just using Decoder Pro, and then they're turning it on and using the Y throttle, you know, to use their cell phone as a throttle, which is very simple. You don't even have to really learn JMRI to do that. Just turn it on and it works. So, but I can, once you make this connection, it's very simple to be able to turn on and off inputs or see what's on and off. So let's go ahead and get started. If you guys caught the post on Google Plus, you'll know that we only need a couple things tonight. We just need, you know, an Arduino, a couple of LEDs. I just grabbed a red and a green LED to simulate a signal light, and of course some resistors to go with the LED, and then that's about it. Well, you have to have JMRI up and running too. So just give me 1 second here. I have to try something here once. Having a little trouble getting my Arduino to accept uploads right now. Trying to get that going right before the show. Anyways, so let me start sharing my screen, and I'll show you what you're going to need to pull this off. Okay, share screen. Try the entire screen and see what happens. Okay, running dual monitors for the first time here, so hopefully everything will work good. So on my desktop, I've got JMRI, and I'm just going to open the Panel Pro version. When you install JMRI, you get Decoder Pro and Panel Pro icons on your desktop. The Decoder Pro icon is just if you want to take a real quick shortcut to, well, this is not sharing, is it? Or is this, you seeing my screen, Johnny? Oh, okay, you are. All right. I got you. All right, yeah, it was just a little slow loading. So you may or may not get this when you've started your JMRI. I just happen to have more than one profile, so I get this little pop-up box. Otherwise, it'll go right in. What you have your JMRI set up like, it may look a little different when you start up than mine does or anybody else's does, but of course. So slowly but surely it's opening up here, a little slower than normal because of all the stuff I have running now. So these are just some of the things that open on default when I open this profile. But as soon as we get the main screen open, come on, you can do it. Here it comes. There it is. So this you'll always get when you open up JMRI. So if you guys haven't set this up before, you'll know you have to go into Edit Preferences. And I'm just going to show you real quick, you know, the connections. Like I run NCE, so I already have an NCE connection on this tab right here. If you hit the plus sign, it adds a second connection, and this is where you would scroll down here and you'll see CMRI. So you can just grab that connection. Then you pick a serial as your interface. And then you'll have to pick the serial port you're plugged into. You don't have to do that yet. We're going to come back to this. I just wanted to show you this real quick. You know, if it's COM port 6, and you might have to pick them once or twice to get it to work to figure out which one it is. But basically, we're going to end up plugging in a USB connection, and that's where you're going to end up having to pick which USB port that is. So right now, don't do anything beyond this. I just wanted to show you, this is all we really need to do to get started in JMRI. But in the meantime, I'm going to go back to the Arduino, and I have the IDE open. So if you don't have your IDE open already, go ahead and do that. And I'll give you a couple seconds to do that. I thought I had another instance open. No, maybe not. Oh, there it is. So I'm going to close that one there. So depending on whatever sketch you had last is probably what's going to open up when you, or it might come up to a blank one like this. But if I'm going to show you the library by opening the sketch, and then I'll come back and do this again because you won't be able to do what I'm doing yet until you install the library. Hopefully you guys saw my message earlier on the week on Google Plus to go ahead and go out and get that library and load it up. But just going to open the sketch to show you right now. There's a library included in this sketch, and it's called cmri.h. And the place that you get it, I'm just going to do it the way I always do it because I don't remember the link off the top of my head. Is got to get used to the dual monitors that you're not seeing the other one. I just go to Google, and if you Google cmri.h, it's going to bring you to a GitHub link for the guy who wrote this library. And it's usually right at the top here. It's called Arduino CMRI, and the cmri.h at Madleach. That's how I always remember it. Madleach is the guy's internet name. So go ahead and click on that one if you see the link for CMRI at Madleach. And from this point, this kind of shows you all about it. I guess it took me to the wrong page. Just if you come up to the same page I'm at right now, just click right here, and it'll take you back to the main page of it where you can download the file. So this is the same as what Dave was showing you last week on how to use GitHub to download a file, or last month I should say. But you just go ahead and click this green button over here, clone or download, then hit the download zip. And from that point, I'm hoping you already know how to load a library. And hopefully it'll just take you a minute or so. I already have it loaded, so I can't go through the process, but I'll just download the library, unzip it, and I can show you where it needs to be when you're done. I'm just going to go through this real quick because we've been through it a bunch of times before, but the more things that I open, the slower this is going to get. So in your Arduino folder, you're going to find the one called libraries, and by the time you're done, you should have an unzipped one in here just called, the folder is called CMRI. And if you double click that, you'll see that there's a couple different things in here. The typical things you would see in a library, including a whole bunch of example files. So I'm just going to give you a couple seconds and I'll talk a little bit while you get that taken care of. I'll leave this open.
Chris, let me just point out that on the Fast Clock GitHub page, I do have a link that has some instructions on how to download and load the libraries from GitHub.
Okay, very good.
So just go out to the, if you need instructions, go out to the Fast Clock page. You can Google it now. It's Google finds it.
So that kind of reminds me, I kind of wanted to just check in real quick and see how many guys might have built a fast clock since we had the show, or if you had any problems at all. I think I promised you we'd spend a little time tonight giving you guys a chance to ask questions or if you had problems. But Johnny, if anything comes up in the chat on that, if any guys are watching and built one and have one working, let us know. It'd be nice to know that. I know mine actually failed, and I didn't have time to get back to it and and try it again. But I was up till midnight the night of the show, and I had a problem with one of the libraries, and haven't had a chance to get back to it. So hopefully nobody else ran into that same problem. I thought it was my liquid crystal display, but eventually I ran tests and got my display working. Sometimes with those displays, they have different addresses depending on what brand you bought. But I was able to figure out what the correct address was, modify Dave's sketch with the address for my liquid crystal display. But I still didn't have any luck getting his sketch to work. It was my display that was causing the problem. But I could get the display to work otherwise of the other sketches. So I meant to get together with Dave and see if we can figure that out in case anyone else had that problem too. So, all right. So I'm gonna go back and depending on what you have open right now, once you have that library loaded, if you go to File, Examples, and scroll all the way down to the bottom, you're going to find CMRI, and these are all different examples he has of to help us learn how to use the CMRI. So I'm going to go ahead and click the Hello World one, and that's what's showing right now. And this one's simple. This one is the way that you want to simply use this to test to make sure that you actually have your CMRI connection up and working correctly. It really doesn't do much for you other than prove that if there's anything wrong, it's in the rest of your code, and it's not that you don't have CMRI connected to your layout, to the Arduino on your layout, I should say. Because once again, all it's going to be is your Arduino connected to your computer with a USB cable. So I'm going to show you that real quick here. Stop sharing for a second. So at the end of the day, all you need is your Arduino, connected with your USB to your computer. Let me go back to screen sharing. So that's a pretty simple connection that shouldn't be too difficult for anybody at this point in time. So basically all we have right now is we have JMRI open, we have CMRI library loaded in, and we've opened a sketch from that CMRI library, and you connect your Arduino to your computer with a USB cable. So that's all pretty basic stuff. That's about as basic as we can get with Arduino right now. So I'm just going to take a real quick swing through this library, and actually if you still have the GitHub page open, that page I was originally on, let's see, I think actually you just scroll down from where you are right here. And this explains how this whole library works in a nutshell. It's not a whole lot to it. I mean, wow, the computer's wigging out right now. I don't think it's liking the two monitors or video card's going bad or something. But we'll take a minute and we'll come back and read through this once we get up and running to kind of understand it. But keep this page open just as we'll use it for a real quick reference to understand what we're looking at in the code. So I'm going to go back to the code now. And this, he nicely set up right here in the code that tells you exactly what it does. It says, sets up pin 13, which is the built-in LED on your Arduino, as an output, and attaches it to the first output bit of an S-Mini interface. So I'm going to give you just a real quick overview. CMRI, the Bruce Chubb's computer model railroad interface, is based on an input-output board, which is basically what we use the Arduino for all day long when we do our programs. So he had a couple different versions, and one of them is called the S-Mini. So you could almost equate, if you had to equate it in rough terms, an S-Mini is comparable to like an Arduino Uno. Then I had another one called the SUSIC, which is, and you'll see those terms probably in and out of here as we go through CMRI stuff, but the SUSIC would be maybe the comparable to a Mega. It has a whole lot more input outputs than the Uno or the S Mini. So think of the S Mini as the Uno version with maybe 16 input outputs. It actually, if you look down here in the code, it actually tells you an S Mini is 24 inputs and 48 outputs. So in Bruce Chubb's world of CMRI, an S Mini would almost be the equivalent of a Mega for us because it has more inputs and outputs. But the SUSIC has a whole lot more. It's like the equivalent of about 5 or 6 S Minis, if I remember right. So every time you see this word S Mini, just think of it as your Arduino. And that's what we're going to be using. So we're using our Arduino to simulate an S Mini. So going back to the top here, sets up pin 30 as an output and attaches it to the first output bit of an emulated S Mini interface. So to set up your JMRI connection, now he actually even has the instructions on how to go up and set this up out in JMRI, which we're going to do in a few minutes. But I wanted to start here and show you this little example called Hello World is really what helps you get this whole thing up and running. So anytime you're stuck, come back and look at that. If you're still stuck, come back and watch this video, and hopefully you can pick up something that you missed in the video. I'll try and go through it thoroughly enough that you can, but it's really not too bad. I mean, once you get through it, you'll see, hey, this was really pretty simple. So, so to set up in JMRI, we're going to skip those instructions for a minute, and we'll go do it. In debugging, I don't even really understand what this means, so maybe somebody else could and jump in if we run into problems, or if you're more of a programmer than I am. But it says open the CMRI monitor window to check what's being sent, and it tells you how to read all this stuff will show up on the serial monitor, and it helps you debug if you know what that all means. I don't, so I'm still basically a beginner. I'm definitely not a programmer, so it doesn't mean a whole lot to me, other than if you are a programmer, that might help you if you have problems figure out what's going on. So that's really all it's to it. When you get down to the sketch, it says to include CMRI.h, that's the library. It starts a command called CMRI, which basically tells it that you're emulating an S Mini at address 0, and that S Mini has 24 outputs and 40 or inputs and 48 outputs. Then we get to the void setup, and it turns on the serial monitor. That's in case you want to go look at this troubleshooting codes, if you understand what they mean. That's the only reason it's there. I don't even use the serial monitor, really. And then it defines pin 13 as an output. So pin mode 13 as an output. Then you go to the void loop, and all it's doing is, and he's got notes to tell you what it's doing. CMRI.process is the main command that basically, and I'll come back to this later too, you'll understand more maybe later, but all it's doing is it's telling JMRI to go read your inputs and outputs on your Arduino and keep track of them. In a nutshell, that's what it's doing. It's constantly polling the inputs and doing outputs as needed. So, and then the last command is digital write 13 CMRI.get_bit 0. So what that means is read pin 13 from what this read, what's in the queue last time you polled it, and if it's 0, then digital write or turn on pin 13. So it's looking for you to tell it to turn it on, and when it does, it will. It's pretty much that simple. It'll make more sense after we go through it again in a minute, if it doesn't make sense already. If it doesn't, it's only because I'm not explaining it well. So I'm going to flip back to JMRI now. Let me just clear all of this off the screen, so I hide that. Let's go back to JMRI Panel Pro, and let's go, so edit preferences. We're going to actually do our connection now. So at this point in time, you should have your your sketch open. Actually, if you haven't yet, go ahead and upload your sketch, that sketch called example. I'm going to go back to it, the Hello World. Go ahead and hit the upload button and upload it to your Arduino. And hopefully mine will go through without crashing this time. I'm not sure what's going on. If I was telling the guys the other night, I was surprised testing my everything because I had, I don't know, probably 6 or 7 different USB things plugged into this computer, and I ended up undoing it all and plugged it all back in. And so far everything's been running, but it looks like the last one that's not is my Arduino. So as you can see, it's a very simple sketch, and I'm still sitting here uploading, which tells me it's probably going to fail. I just got to see if it's a matter of the right COM port or if it's something else. So I'm going to give it a second to do that. Hopefully yours uploaded, and we'll go back to JMRI, and I'll come back and look in a minute. I'm not going to waste my time just staring at it. So I'll clear the screen for you. So from Panel Pro now, let's assume that you've already uploaded the sketch. Go to Preferences. Oh, you know what? Yeah, that's a real... I'm actually going to... apologize here. I've just thought of something. I already have that window open. Here's one little caveat that you're going to have problems with if you're not careful. You can't have your Arduino IDE open and be uploading to your Uno and have your connection open to JMRI. So this is one thing that's kind of a pain. You have to go back and forth. If you have your Arduino and your JMRI turned on, but you want to change your sketch, you have to literally close JMRI, open up your IDE, and then upload your sketch, and then close that and open this. Even if you're using a different COM port, like I was trying to do, it just works best. You can't program to the Arduino while it thinks it's being a part of JMRI, is what it boils down to. That's something a little different than we've done up to this point, because all the stuff we've done has been standalone, wasn't connected to anything. Well, now as soon as you plug in that USB and you have the JMRI running, it thinks it's part of a system. So now when you try and go program to it while it thinks it's part of that system, it just doesn't like it. So I'm just wondering if that's why. No, it isn't why, because I haven't set up this connection yet. So, but I'm just going to go back and check on how we did here. This is still, no, it failed. So I do want to get mine set up first and running before let me give it one more shot. Because of the fact that I'm going to be having to be unplugging back and forth, otherwise, nope, that one failed. I got a 4-port hub that I added, so now we've got to figure out what all the darn ports are again.
Well, one of the quick ways I found to do it is if you unplug it, see which one disappears, then plug it back in and jump, plug it back into the same port. And
I found it now. So as you see now, I'm done. It says done uploading. So now I found it. If I go back and look, I'm actually on COM port 5 for the Arduino IDE. So once you get your IDE loaded up, go ahead and just close it out so that Arduino isn't seeing that or caring that it's there. So then we come back to JMRI now and create this CMRI connection like we were doing before. Boy, if I keep saying MRI all night, we're all going to be going nuts here. CMRI, JMRI, CMRI, JMRI. Anyways, so CMRI connection, serial. Now I'm going to go ahead and select that same COM port 5 because I didn't bother to unplug my Arduino. And now you can name it anything you want. I'm going to leave it by the default as CMRI. And for those of you who haven't used JMRI much in the past, you can just leave this where it says connection prefix C just leave that. That's something you'll end up using later, but accept the default settings. Now you notice there's another thing here. It says additional connections. You go ahead and click that. It's really just the baud rate. So you can leave the baud rate at 9600 if you want. It doesn't hurt anything. So the next thing you want to do is go ahead and hit save. And what it's probably going to cause you to reboot, or it'll not reboot your computer, but restart JMRI. If you've set up connections, you're familiar with this. So I hit the save button. Oh, actually, it's not asking me to. Either that or it's just for, oh, there it is. So go ahead and restart. Hit the restart button when it says that. All right, now I'm going to select the same profile. Just wait for this to slowly start. If you hear a funny noise, that's just my dog panting. Came down here and he's must have been a little bit of thunder now, so he's freaking out. He becomes my best friend, inseparable when there's thunder. He's got to be hanging on my leg, so to speak. Not that way, but anyways. So go back to Edit, Preferences, and you'll see that that CMRI connection is here now all set up. The last thing we have to do is go ahead and set up the S-Mini, so to speak. So if you say Configure Nodes, the way CMRI works is I'm going to just hit the Add Node button, then I'll continue that statement. Each S-Mini or SUSIC that you have, and you'll also see one on there called, what is it called, CP node or something. That's for a different board you can buy from somebody else that works with Bruce Chubb's system. Each one of those boards, in other words, like if you had multiple Arduinos, each Arduino is a node. And then node is made up of bits. So those are the two big words that you really need to worry about for this whole darn thing is nodes and bits. So if you notice, going back to here, I hit the Add Node button at the bottom here. So all we're going to do is define our Arduino as a node. And it defaults to -1. And I'm not sure why. Uh-oh, what's going on here? It's freezing up here. Should be able to change that. Oh, here we go. Let me try it again. So add node, and you'll notice right away the cursor was flashing in there. So erase that -1. All the nodes have to start at, it starts at 0 and goes on up in positive numbers. So your first node could be 0. Your next node would be 1 if you added a second or third or fourth Arduino, which you cannot do using USB, by the way. That's going to be a future show coming up when we want to connect multiple Arduinos for our system to have them all talk together through a network. But for now, all we just do is set this to 0. And the node type is S-Mini. If you drop this down, you'll see there is the SUSIC and the CP node, but for now, just use S-Mini. The rest of this you can pretty much ignore. If you see this little matrix here, the only thing this whole matrix is for is if you're using LEDs in a searchlight signal that are the 2 lead LEDs for red, yellow, green. You know, we only have 2 legs on them and they flash their green and yellow, the green and red back and forth to make yellow. If you're going to be doing that, you'll have to deal with this, but that's kind of out of the scope of what we're doing tonight. But that's the only thing this whole matrix is for. So if you don't have signal lights on your layout that have 2 lead bicolor LEDs, you can just ignore this altogether. All you really need to do is set this to 0 and say add node and done. And then it gives you this little reminder. Remember to save your node information to disk. Use the save button in the preferences window. So just a friendly reminder. So I'll say okay. And if you really want to do that right away, then you go to, let's see, I think you got to go back to, I think you got to have a table open. That's we'll ignore that for now. I'll come back and show you that later. It's kind of too much of a sidetrack right now. So at the end of the day, it says configure nodes. You'll have address 0, S-mini, 24 bits per card, 3 in cards and 6 out cards, 24 bits in, 48 out. It's you don't have to get too concerned with that, other than the fact if you were going to use that matrix that I was just showing you. The main thing to understand is that you have input bits and output bits, same as pins on your Arduino. So where it says in bits and out bits, that'd be the same as pins on your Arduino. The S-mini is actually broken up internally into 3 input cards and 6 output cards, because there's 8 bits per card. That's how you get 3 times 8 is 24 inputs. And like I say, you really don't have to care a whole lot about this at this point. Maybe down the road, if you get really complex with this, you would. But all you need to know is there's 24 input bits and 48 output bits. So you can hit done. So that was a long, drawn-out explanation on something that really only takes about 30 seconds. All you do is hit configure nodes and hope that it pops up again. Go add node, make it node 0, and you'll end up back at this screen and say done. So it was really all that just for that. So I hope I didn't bore you to tears, but just helps to know a little bit of the backstory so you don't get too messed up with this. So at the end of the day, we have a CMRI connection now, along with a node configured. And we have our Arduino loaded with a sketch. And the last thing we need to do, here again, just go ahead and hit save because we configured that node. That's what that message was for, I guess, is we wants us to hit save here. And if your computer is not too slow, it's going to ask you to reboot, or maybe it won't because it wasn't a big enough change. But you're going to see something different now. There's an additional tab across the top here called CMRI. So you can go back if you ever need to reconfigure a node. Here it is again, configure node. And then the only other thing you really need to care about at this time is list assignments. If you click on that, this is where we actually will end up defining our input and output bits. So you notice it says node 0, that's the one we just created. And if I hit the down button there, aren't any other ones. If you had multiple nodes, you could change to the node you wanted to program. And then there's show input bits. So if I hit that radio button right now, there's a list of empty slots, so to speak. These are our input pins, and these are our output pins. They're all empty because we haven't assigned anything yet. So let's go back now that we have this running. Actually, look at your Arduino, and right now all you should really see is the one red light on it. Does anybody see it flashing fast between transmit and receive, the little LEDs that are built on? Yeah, it should be just the one red LED. Now what we're going to do is something very simple, and you're going to see this thing light up and go into action. So if you go into, just minimize this so you can see it better. Go into Tools, Tables, and do one called Lights. And wait for a table to pop up. If you hit Add, and it's going to ask for the system connection. These are the two, I had NCE before, and now I created the CMRI. If you go ahead and call it CMRI, and now it's asking for a hardware address. We're going to call it 1. And then the username, I'm just going to call it pin 13. That's going to be our LED on pin 13 on our Arduino. I'm going to say add control. That's going to say control type. Let's just say by sensor. And go ahead and hit create. Oh, we can't. We have to go back and create a sensor. All right, so leave it to none for a second. I apologize for that. Jump ahead of the game. I'm going to cancel out of this. Go to the one where on the left where it says sensors. We're just going to, this is basically going to be your on-off switch. We're going to just create a sensor. So down here it says add and leave it at internal because we don't have an actual hardware sensor. We're just going to make a computer sensor. Well, here again, I'm just going to call it 1 and I'll say pin 13 switch. This is just going to simulate a push button, let's say. I'll say create. So now let's go back. What this did was just created a JMRI, just a computer simulated push button. So let's go back to lights, go back to add. I'm going to call that hardware 1. We can call it 1 again because 1 is a light and 1 is a sensor. It doesn't care. You can reuse that number. I'll say pin 13 LED this time.
Do you need to change your sensor connection at the top?
Oh, yes. Yes. Thank you, Dave. Change your connection to CMRI and say add control, control type by sensor. And the sensor is pin 13 switch. And go ahead and hit create. And down here you can just say create. Whoops. Oh, I guess it doesn't like. All right, so I lied. Let's call this 2. It shouldn't care. I think it's because of the one I created and didn't kind of cancel out before. Nope. I'm getting
I think it's the name. It's saying username already exists.
Oh, okay. I'm just going to call it 13 then. Yeah, you're right. I didn't read it carefully enough. Username already exists. So create. There we go. And then I can close this. Now it's reminding you again to save your configuration. If you care, if you're going to go beyond this, I'll show you how to do that real quick. I'm going to say OK. If you go to File, Store, and it says Store Config, it's kind of a goofy way to save. If you're not familiar with JMRI, I really wouldn't worry about this at this point in time, but we're just going to say Store Configuration only to a file because we don't have a panel, and I'll just call it Test1 and save. So what this did was this allows you to open it up again later once you close JMRI. If you don't do this, this will all be gone next time you come back into JMRI. Oh, I see what happened. I went ahead and added it twice. So you notice that pin 13 LED is here. But and then the sensor, if we go back to sensors, we can see the pin 13 switch. Here's how you can turn it on and off. Right here with the state, it says unknown. No, it's not going to let me really. That's going to work. So right now, if you actually go to the pin 13 that you created and click it on and off, you should see that light going on and off on your Arduino. It's just kind of weird because normally the transmit and receive lights usually go back and forth as it's polling, so they'll flash continuously very fast on your Arduino. So something's not quite right here. I got to see if I can figure out what that is. But is everybody having luck seeing their LED go on and off as they turn this state button on and off? I guess I didn't even need to create the sensor for this one. Anybody seeing it or anybody not seeing it? Or is nobody else doing it right now? All right, so just to go back now and look, if you go back to the CMRI menu and the list assignments, you can actually see now this auto-populated. So here's the two lights that I created. Those are outputs. And it should be showing the one sensor I did as an input, but it's not for some reason. I did that as an internal. That's why. Okay. Let's go back real quick then to tools, tables, sensors. I'm literally going to delete this one that I created because I'm not going to use it. And I'm going to create a new one. I'm going to say add, and I should make this one a CMRI, which I didn't before. I left it as internal. And I'll call it 1 and 13 switch. Switch, that's good enough. Create. There we go. So now I'm going to show you. Stop sharing for a second. This is what I was missing before. I'll show you on my camera. See how the lights are rapidly flashing back and forth, and they're actually flashing much quicker than just the frame rate is making it. So that's CMRI constantly polling your Arduino inputs and outputs. If those two lights aren't rapidly flashing like that, then you're probably, what it's telling you is you don't have an input and an output. I'm going to go back to screen sharing and show you that now. If I go back to, come on. Wow, this table for some reason just freezes up on me. The rest of them are okay. There it comes. Oh, sorry. There we go. So now if you look, when I click on the inputs, this showed up on the list. And when I click on the output, you'll see the other two times that I had set up a light for pin 13. But the whole trick is as soon as you have one input and one output, you're going to see those two lights flashing. That activates the whole thing. So you won't see them flashing until you have one input and one output. So the only other thing I really have to show you here, and this is the real gotcha where I think a lot of people have had problems, is for some reason in JMRI, the bits are numbered 1 through 48, and the addresses correspond. If you go to the library that the guy wrote, let me bring back the Mad Leech library here. And he even refers to that in here, if I can find it. But when you program your Arduino, it might be easier to show you the sketch. I'm going to reopen. Oops. Let's reopen the example. Hopefully this won't screw anything up because they're both running at once. Hello world. If you notice on here, it says get bit 0. That's actually bit 1 in CMRI. So I'm going to bring this list assignment up. This is where it gets really screwy. You have to always remember to subtract 1 in your programming from what it says here. And this is why I think guys have had problems, because once you understand that, and like I said, I think there's reference to it in his GitHub site, but bit 1 in here is actually, when you program, you have to call it bit 0. Bit 2 would be bit 1. Bit 3 would be bit 2. So you always have to subtract 1. You know, that is where people, I think, have had no luck getting this thing actually running. Because if you look at, I'm going to go ahead and, just for clarity's sake, go back to my tables. Nope, not that one. Oh, I went past it again. So if I go to my lights here, I'm going to just delete one of these pins. I don't need them both. Whoops, let's do that one. So now I only have one showing. If I go back to this bit and let it update once, show input bits, show output. See, now it updated. It left address 1 empty. It left address 2 with the one I put in there because that's the address I gave it. This address corresponds to what you gave it back in the table. Let me bring the table up here again. So I'm hoping this makes a little bit of sense to you. But you notice if I go back on here, CL2 is the system address. All you care about is the 2 number. So that's this one. CL2 is address 2 at bit 2. But in our programming, you have to call that bit 1. So right now, mine actually isn't going to do anything if I click on that button, and I'll do it just to prove it. You won't get to see me do it, but state on, state off. So my LED is not turning on and off as I do this right now because of the fact that I deleted what was at address 1. This is now address 2. So if I go into my code and change this to a 1, because remember we have to, that's like I said, the confusing part. If I put in a 1 here now, that would match bit 2. So whatever this bit number is, you have to subtract 1 when you program it. Can't stress that enough. This isn't going to work correctly if you don't do it. And that's really the weird part about it. So we've been through 90% of it. The only thing left really to show you now, other than to let you start getting, is I'm going to come back now and show you what these meant again. So this CMRI-CMRI is what launches this whole process. But this CMRI process, now what that's actually telling it to do is easier if I show you. I'm just kind of losing my thought here. The dog is driving me nuts because of the thunder here. Running circles around me. And all right, so going back to the GitHub page, once you read through this, and I'm going to let you do it mostly on your own, but I'll highlight the important part. There's 2 main processes that you really care about to get started with this. And it's, let me see if I can find where they are here. It's basically get and set. And the format for those are, I thought it was in here. Get the CMRI get bit and the set bit. So get bit is like read the pin. All these times we do a digital read or a digital write on our Arduinos. That's what basically the CMRI get bit. So CMRI.getBit says go back, see what I read last, and then act on it if I have to. So I'll digital write to pin 13 if the get bit 0. Oh, excuse me, I'm getting all screwed up here. CMRI get bit, if that bit value is 0, go ahead and turn on the light, is basically what it's telling you. If it's not 0, or I shouldn't say if it's 0, that's the address, I believe. So
Yeah, I think what you're trying to say is the get bit, the end is the bit that you want to get.
Right.
You want to read that one.
The easiest way to think about it is, okay, they got those 2 lights are flashing back and forth, read and transmit, read and transmit. So CMRI is going out to the Arduino and polling the pins. So if you have a sensor pin, it's watching the state of that sensor pin, high or low. So that's, and then it's doing the set bit would be when it meets a certain criteria, like whether it's high, then turn it on, or whether it's low, turn it off. So it's just constantly polling the inputs and doing the outputs accordingly. That's about as simple as I can put it. And it's just a combination of set bit and get bit. So in order to make that make more sense, what we're going to do is go ahead and open up another example. So if you go to File in your Arduino IDE, Examples, scroll down till you find CMRI. The next one we'll do is Input and Output. It's right below the Hello World. This will show you, make a little more sense to you now. So I'm going to skip all this because all this at the top is a repeat of what was in. It tells you how to set up JMRI again. And get down to the void loop because the rest of the void setup is the same. And load the library, start the process, or define the CMRI as an S mini. Start your serial. Down here, digital read or digital write pin 2. These were all set to be L. Somebody's making a bunch of noise. Could you please mute?
Is it me? I'm sorry.
It's getting okay. Thank you. Can't hear myself think. Digital write 2, 3, 4, and 5. Okay, these are all LEDs that were defined up here. So this one is saying for LED that's on pin 2, read bit 0. For the LED that's on 3, read bit 1. For the LED that's on 4, go and read what's bit 2. And down here, the set bit, it's going to say, okay, set bit 0, go read pin 6, which would be we go back up here. I'm sorry, I'm losing my train of thought again. I apologize. I'm just losing it here. So those are your inputs, pin 6 through 9. I should have read this up here so you guys know that those are actually sensors, so to speak, that were set up. But this sketch right here will help you understand. I had to go through it a couple times to really make sense out of it. Between the hello world and this bit here, you can kind of get the hang of using the get bit and the set bit. And since I lost my train of thought, I'm just going to go ahead and I'm going to open up
I think what you're trying to say is if you're looking at that line, let's say it says the digital write 2 get bit 0, what it's doing is it's saying go get bit 0 from the CMRI and set the Arduino pin 2 to whatever value is in the CMRI table.
Yeah.
So whatever CMRI says it should be is what
high
you're setting PID 2 to. Correct, high or low. And down here under the set bit, you're saying tell CMRI to set bit 0, as far as CMRI knows, to whatever the Arduino bit pin 6 is.
Right, so whatever your push button or whatever other input you have set to it. That's a good way. I just know I was having a hard time getting to that tonight, but yeah, that's the gist of it. It's, and once you understand that simple concept, that's what this entire thing is all about. So now all you do is you take, if you want to add this to a sketch where you have like LEDs for lights, and I was going to try and get that to tonight, but I don't think we're going to get that far. Maybe we could do that next show if there's enough interest. But all you have to do is start interjecting these commands into any other sketch that you have. Load the library, run this, add this line right here to define your S mini. You don't have to do this. This was just a fancy way for him to define 6 outputs all at once using I equals, he could have had 6 lines or 5 lines defining all those outputs. He just did it fancy doing it all in one line. Same with the inputs. But then the key is to this one right here. After you have the library, you start this process. That process is it actually, polling the inputs, constantly updating the outputs. And then, I mean, it's doing the polling, and then it runs through these routines. And like Dave said more eloquently than I've been able to do it tonight, is this dog is driving me crazy. Very distracting. Sorry. These set all these according to the bits that it gets, and then go back and pull the inputs and set our CMRI to those. And what that is doing is actually literally going into the table. I'm going to go back to your JMRI table. No, I must have closed it. So let's go back and no, I didn't. There it is. So like on the sensor table, that's your output. It's actually, you could watch it change here. If I actually had a push button out on the layout and I changed it, you would see it change right here, active to inactive. Or like here, if it was state on and off, if I had a push button out on the layout and pushed it, it would change the state here too, because it's also, tying back and forth. Sensors are inputs, lights, and turnouts, which is a weird thing about JMRI. They call turnouts is not necessarily a turnout as you know it in model railroading or a switch. It's an output. So sensors are input, turnouts, and lights, and you really should only use turnouts. Lights is an old way of doing it. That light is the same thing. If you think in JMRI terms, light would be the same as a light switch. It's basically an on-off switch for anything. It doesn't have to be physically a light. It could be anything. It could be to, like whoever did that garage door going up and down. It could be to turn it on, turn it off. A turnout is the same. They call it closed and open, but it's literally the same as a switch also. But there's a whole lot more options once you get into edit, which I'm not going to get into. It's beyond the scope of tonight, but I'll just show you the difference in a turnout. There's 1, 2, 3, 4, 5, 6 tabs of things you can do with it. If I go to a light and hit edit, there's no tabs. It's just what you see here. So one is super simple, like an on-off light switch, where the other would be a fancy multi-LED controller, if you would. They can change flashing random patterns of different colors. I mean, there's so many different things you can set on it. So my recommendation, if you're getting started in JMRI, ignore lights, pretend it doesn't even exist. Use turnouts for anything you want to turn on or off, and use sensors as the way to do that. Any kind of sensor, whether it's a push button, an infrared sensor, any other kind of sensor you can think of, a sensor from something on your LocoNet, or that's the real power of JMRI, is you can actually have a LocoNet connection, an NCE connection, a CMRI connection, all feeding at the same time, feeding each other. So I have, I'm going to show you real quick, and then we'll get back to this. I'll tie it all together. I'll show you what I have set up, and it's going to involve shutting this down and restarting it. So I'm going to show you when I first launched this, I had multiple profiles. This one is just an experimental profile, and the one I start up is the one I actually use for running my model railroads. So you can get CMRI mull and pass. I'm going to close this stuff so you can watch it all launching. So the first thing it does is ask me to open a file that I had saved. Which one do I want to? So I usually have an experimental one going, as well as the one I called master, which is proven to be good before I started my next experiment. Gives me a fallback if my experiment fails. So the first thing it did was open up Y throttle. That allows me to use it. Then it opens my layout panel. Then it opens up a route table. which has a bunch of routes for my staging yard, meaning throwing a bunch of turnouts all at once to line up for a certain track. But if you watch carefully along here, you'll see that all the switches, this is a diagram of my layout, all the switches opened and then they all closed and then they all activated and then they all deactivated. They turned red and then they turned back to black. So right now what I have set up is I have an Arduino set up on the layout, and if I click this, it throws my servo driven turnout, the same one I've showed you many times before, the only one I have on the layout right now. And it also has a sensor that I think I might have showed you guys last month. I put an infrared sensor under the points so that from this control panel I physically cannot throw that switch, or it won't let it throw the switch while a train is on top of it. So let me take a walk over there, put a piece of rolling stock on top of that, and you should see this light or this turnout right here turn red as in being occupied. Let's see if that worked. Yep, it did. Okay, so now I just laid a boxcar over the top of the tracks there so it stays occupied. While it's occupied, when I click on this, I literally cannot throw that switch. You notice the lights, these are actual signal lights on the layout. Those all change too to red. You know, it's the only occupied sensed block I have on the whole layout right now. But the way I accomplish that, so that's enough of that. I'll show you that, but I want to show you going back to configure nodes. This is the same thing we just did. So I have one S Mini at address 0, just like I showed you earlier. Go back to this CMRI drop down in your Panel Pro. List assignments. So besides that servo-driven, Arduino-driven servo turnout, I have servo-driven turnouts that are tied into my NCE system with decoders, or with a Tam Valley octacoder. Handles 8 servos at once, but it controls them through my NCE system. So you'll notice that right now, if I look at my list, here's my node 0, where my mouse is going. If I show output bits would be all those turnouts, as well as the LED lights up at that switch that I just showed you. So you'll notice I have like 19 output bits being used right now. And that's basically for 8 turnouts and 4 signal lights, or 4 signal heads, I should say. But you look at the input, I have these all set up, but I'm not really using any except one. I have these set up for the future, because in the near future I'll be adding current detection block detectors. So I have them all set up, but they don't actually do anything right now. But here again, going back to that gotcha that I was talking about earlier, this bit 1, if I want to address this on my Arduino, I have to call it bit 0 when you get the get bit and the set bit commands. Remember, you have to use one less than whatever this number is. So if I want this one skyline block right here, address 0, if I want to throw that or show that block as being occupied, I would go do the get bit command, and I would have to call it 6, not 7, even though it says 7 here. Always remember, you got to subtract 1. But the actual one that I'm using, let's see, that would be the East Blossberg block. So this one right here is that turnout. I don't have the code handy to show you. I'd have to go to my online version, and I think we're running out of time. But in that code for my Arduino, this would be bit 5 in the commands, to show that as being occupied or not. So I know it seems like a lot, but if you go back through it and actually do it, you'll see there's not a lot to it. I just wanted to explain it as good as I could because of a couple of those little gotchas, but in hindsight, if you think about it, it's really pretty simple. You load the library, load an example sketch on your Arduino, you start up JMRI, you create one turnout and one sensor, then you just create the CMRI connection and add one node, and you're done. Then it's from that point on, the only thing difficult about it is understanding and coding the Arduino itself, and that's where, let's go back to Mad Leech, save this, read through this a couple times, and it'll make a lot more sense to you. And he also explains how to do everything that I learned basically came from right here and from what was inside his sketch and then just playing around with it. So, here's what I was looking for before. The main loop is where the magic happens. The CMRI process receives data from the PC and processes it automatically, responding to the PC if required and updating its internal state. Basically what it's saying is it's reading JMRI and updating as necessary. To access the data we sent it, we use CMRI get bit n, with n being the number of the bit. And then goes on to read the rest of it. So it's all kind of rehashed. There's some other things you can do with it here too. But that's stuff beyond what I needed to do, or probably you guys needed to do, unless you're getting to something really advanced, in which case you don't need my help. I'm not going to be able to help you anyway. So it's really, if you boil the whole thing down, it's in, come on, clear up. It all comes down to those three things within it. It's the CMRI process, it's the get bit, the set bit, in your Arduino programming. And then it's the remembering that the bit number you use is one less than what it shows in JMRI. I don't know why the guy didn't program it to match, but the one that starts at 0 is technically correct. It's whoever programmed JMRI and had it start at 1 instead of 0 is probably where the problem lies, but I may be wrong with that. So,
well,
anybody have any questions?
I say, Chris, that's only because most people think of, they reference numbers starting at 1, and computers reference starting at 0.
Everybody knows, right? When you talk in bits, it always starts at 0.
Yep.
All right. So, anybody got any questions out there in YouTube land, or no? All right. So hopefully, feel free to email me if you have any questions, or watch for me online. I've been starting to get on a little bit more now in the evenings, but this was really exciting for me to, once I worked through this and got it actually working on my layout, because that's what I've been working toward the whole time, is I don't have to run out and buy $20, $30, $40 boards from people now to do stuff. I can do it myself with a couple dollar Arduino. So it was just a matter of cracking the code, which I managed to do. So I wanted to share that with you guys. And if you're stuck with it, just shoot me an email and I'll get online with you and help you work through it. So, because I think this one is really important as far as guys that want to use JMRI, and then just, even if you're already using it with your local net or anything else, if you want to start adding Arduinos, this is the way to do it. Or you can run out and buy a $40 LocoNet shield, or you can do like Greg is doing and spend mega hours and probably lots of money to boot, creating your own. They'll be cheap when he's done, but the cost of prototyping them isn't. So
but that's half
there's always
fun.
that. I know. But that's pretty much what your options are if you want to tie Arduino into your computer, JMRI or anything else. So, all right, with that, I think we'll stop sharing, get my camera back in shape here, and call it a night if nobody has any questions. And I'll hang around for a few minutes in the YouTube Model Builders Arduino appear-in room. If anybody had any questions they didn't want to ask or was too much to type, I'll stick around for a few minutes, but then I gotta head to bed early. I was up way too late last night, so with that, we'll see you guys in July. So, Johnny, close her up.
Alrighty. Just want to say go to YouTubeModelBuilders.com. There you can check schedules for the Tuesday, Wednesday, Thursday shows. Tuesday and Wednesday are at 8 o'clock Central, 9 o'clock Eastern Time. Thursdays at 9 o'clock Central, 10 o'clock Eastern Time. And our next show will be next week. That's going to be May the 8th. That's going to be the Fine Scale Show with Andy, Miles, and Ralph. Yeah, Ralph's a little out of town right now, but he should be back in time. May 16th is going to be into the locomotive shop with Joe Desmond. And of course, Mr. New Yorker, Big Bill, will be the host there. So, anyway, we got the Johnny Mall Train Talk Show tomorrow night. That's 9 o'clock Central, 10 o'clock Eastern Time. And like I said, next month, Chris is going to have to take off, so we won't have a show there. And we are doing a little checking around, and we may wind up doing a little rescheduling for the summer months with everybody being out. Right now, things are not quite concrete yet, but as soon as they are, they'll be on the schedule at the website. I want to thank everybody for coming in tonight, and we appreciate it, and we shall see you tomorrow night. All right, have a good one.